Welcome back. This is Basic Chemistry by Karen Timberlake, Section 7.4, Percent Composition and Empirical Formulas. Percent composition is how much of one element is in a compound. So if you were to have H2O, which is water, how much of that mass, let's say you take a gram or 100 grams or whatever you want, how much of that 1 gram or 100 grams is hydrogen? How much of that 1 gram or 100 grams is oxygen? That's the percent composition. How much of each element inside a compound is the component of that composition, or how much of the compound is each of its components. An empirical formula sounds really hard, but all it is it's the smallest ratio of the elements that's in a compound. So if I were to give you something like H2O, I can't break that down any further. Like I can't divide both sides by 2 because oxygen only has 1, so I can't divide it by 2. So it's already as low as it can get. So even though this is the molecular formula, this is the formula of the molecule, it's also the empirical formula because it's the smallest ratio of whole numbers that there are. If I were to give you something like this, C6H12O6, which is sugar, I see that I've got 3 even numbers. I've got 2 6s and a 12. 2 will go into both of them, 3 will go into both of them, and 6 will go into both of them. So if I divide all 3 of these by 6, I've got C1H2O1. This is the empirical formula of this molecular formula. The molecular formula is the formula of the molecule. What does that molecule in nature actually comprised of? How many carbons? How many hydrogens? How many oxygens? How many whatevers? Okay. The empirical formula is the smallest ratio of all of those elements. So we'll look at that at the end. That's really easy. So tiny bit of math, but I would call all of this very, very simple, and I think you'll be able to do it fine. So percent composition is going to be the grams of each element divided by the grams of the total. Okay, so if you have 100 grams of water and you know you have so many grams of hydrogen, that hydrogen grams divided by the total water grams is the percent of hydrogen. The amount of grams of oxygen divided by the total amount of water is the composition, percent composition of the oxygen. Okay, so here's an example. Calculate the percent composition of carbon dioxide. Well, I need to go to the periodic table and I need to look at the mass numbers. I find from the periodic table that the mass number of carbon is 12.01 and the mass number of oxygen is 16. Okay, so let's just look up at the top for a second. If I have carbon dioxide and I know that I've got 1 carbon and that carbon is 12.01 AMUs, so 1 times 12.01 is 12.01. I've got 2 oxygens, and oxygen is 15.9994. That's what it says on the periodic table. Okay, so it's close to 32, so 15.9994 times 2 is 31.9988. Okay. So I'm going to add those two together because the 12.01 is the amount of mass of the carbon, and the 31.9988 is the mass of the oxygen. Okay, so when you put that together, I get a total of 44.0088. Okay, now let's do it in each step. What is the percent composition of carbon? Okay, well, I know that in that molecule I've got 12.01 grams out of 44 44.0081 grams, or 88 grams. Okay, so the 44.0088 is the amount of weight of carbon dioxide. The amount of the carbon in that carbon dioxide is 12.01. So I'm going to divide that out. 12.01 divided by 44.0088, and I get 0.2728999. Okay, well, that's the same as 0.27. What's the percentage if you have 0.27? So if you have a decimal of 0.27, what is that as a percent? You multiply it by 100%, and you end up getting 27%. Okay, 27% carbon. What about percent of oxygen? Well, remember there's two oxygens. The total of the oxygen's weight is 31.9988. The total for the molecule was 44.0088. Okay, so 31.9988 divided by 44.0088 gives me 0.7271, okay, which is rounds to 0.73, which as a decimal is 73% oxygen. Okay, so 27% of the carbon dioxide is carbon, and 73% of the carbon dioxide is oxygen. Here's an example. What is the percent composition of lactic acid? Lactic acid that appears in the blood after vigorous activity. It's what makes you sore after you exercise, is the lactic acid in your muscles. Well, I know that carbon is 12.01 grams per mole. That's the number on the periodic table. I've got 3 of them. So 12.01 times 3 is 36.03. I have 6 times 1.00794. That's hydrogen. I just looked on the periodic table. 1.00794 times 6 is 6.04764. And 3 times 15.9994. 15.9994 times 3, 47.9982. Let's add that together. And I get a total of 90.0758. Okay. All right. So what is the composition? What's the percent of carbon? Okay. So carbon is going to be the carbon number, 36.03, divided by the whole number, 90.0758. Which is 0.399. Okay, so 0.399 is 0.40. 0.40 is going to be 40%. So 0.40 as a percentage will be 40%. Okay, just like 40%, 40 cents out of a dollar, 0.40 would be 40 cents, 40%. Okay, the next one is going to be the hydrogen. So the hydrogen is going to be a total of 6.04764 over 90.0758. 0.04764 divided by 9, 0.0758. Okay. It's 0.067, 0.067, okay, which is 6.7%, probably rounding to 7%. Okay. It's not very much because hydrogen weighs so very little. And the last one is oxygen. Oxygen's total was 47.9982 over 90.0758. I've got 0.533, okay, which is 53%. Okay, so let's see if that makes sense to us. 53 plus 7 is 60. 60 plus 40 is 100. We're always heading towards 100%. Okay, so this is your answer. Carbon is 40%. Hydrogen is 7%. Oxygen is 53%.